All right, everyone. This session we're going to revert to Module 8 to talk about the network traffic management in Azure. So my name is Robin, and this we are closing to our final session. Actually, there are 12 modules, and we are down to Module 9 now. Of course, it's the revert one for Module 8, right? So, well, this means there are only uh, like three module left, so around 6 to 8 sessions left for this. So I'm also thinking about after this, I might do a, MS 500, so exams that's on the security of Microsoft Office 365. Or I will also do another MS 101 or 100 on Microsoft 365, generalized of the knowledge. But anyway, I will decide that once this is finished. Okay, let's get started. So this one will be divided into 3 sessions as well, and we'll talk about the first two network routing and the Azure load balancer in this session, and we'll cover the Azure Traffic Manager in the following one. And you can find in the description below the comment that we'll be uploading the stacks to a SharePoint site where you can download the PDF version of this. All right. Okay, so that's first about the network routing. We'll be covering this in 6 points, so system routes, user-defined routes, examples, and we're creating a routing table, a custom route, and associated route. So actually the last 3 parts is combined. It's a step, more like 1, 2, 3. Okay, so let's first talk about the system routes. So Azure uses the system routes to direct the what we call the network traffic between your virtual machines, on-premise networks, and the internet. So the following situations are managed by these system routes. So the traffic between VMs in the same subnet, the between VMs in the different subnets in the same virtual network, or from data flow from VMs to the internet, communication between VNets using the VNet to VNet VPN, VMs using VNet to VNet VPNs, and also the site-to-site or express route communication through the VPN gateway. So let's say for example, consider the virtual network with 2 subnets here. So communication between the subnets and from the front end to the internet are all managed by Azure using the default system routes. So information about the system routes is recorded in a route table. So this is more like if you ever take the CCNA test or you study the CCNA class, or you have the CCNA level knowledge whatsoever, right? So you know what the route table is. So the route table contains a set of rules called routes. It's not really exactly the CCNA, but similar. So let's specify how packets should be routed in a virtual network. So routes tables are associated to subnets, and each packet leaving a subnet is handled based on the associated route table. So packets are matched to routes using the destination. And the destination can be an IP address, a virtual network gateway, virtual appliance, or internet. So if a matching route cannot be found, the package is lost. No, sorry, not lost, it's dropped in that case. And we have actually two, we talk about the user-defined routes first, right? So as we explained before in the previous topic, so the Azure automatically handles all the network traffic routing. But what if you want to say do something different? For example, you want to have a VM that performs the network function like routing, firewall, or WAN optimization. You may want certain subnet traffic to be directed into this virtual appliance. For example, you might place appliance between subnets or subnet and the internet, like what we saw here. So in this situation, you can configure user-defined routes. We call the UDRs. UDRs control network traffic by defining routes that specify the next hop of the traffic flow. So this hub can be a virtual network gateway, a virtual network, internet, a virtual appliance, etc., etc. So we talk about there are two routes, right? So the first one is the system route. The second one we call it the user-defined routes. And each route table can be associated with multiple subnets, but a subnet can only be associated to a single route table. So it's more like a many-to-one situation. So there is no additional charges for creating route tables in Microsoft Azure. So you have to judge whether you need custom routes or not. Right. So let's give an example here, right? So let's say the specific network routing example. So in this example, you have virtual network that includes three subnets, right? 10.0.0/24, 10.0.2, 2.0, 10.0.1.0, also 24, right? So it's 255, 255, 255.0. So the subnets are private, DMZ, and public. So in the DMZ subnet, there is a virtual network appliance, or for short NVA, are the VM that helps network functions like routing and firewall optimization. So you want to ensure all traffic from the public subnet goes through the NVA to the private subnet, right? Like we saw here. So in this way, we have to create a routing table, create a custom route, and associate the route to the subnet, which we're gonna do actually I'll do a demo later for the three steps. It's actually very easy, right? It's very easy. So creating a routing table. So creating a routing table is very straightforward. So you must provide name, subscription, resource group, localization location, and where to want to use the board gateway protocol route propagation. So the one before you should be really familiar with, right? The names you must be unique, match their requirements. Subscription you might choose one, just basically which credit card you pay, and yeah, this resource group you must place in and location of this routing table, right? You must do this. So we introduced the BPG, GBP, sorry, Border Gateway Protocol, right? So this is a standard routing protocol commonly used on the internet to exchange routing and you know say exchange information between two or more networks. So routes are automatically added to the route table for all subnets with a BGP propagation enabled. So in most situations, this is what you want. For example, if you are using express route, you want to, all subnets to have that routing information. Okay, so it's by default enabled. Actually, you can choose to disable that if you want. So the next step is to create a custom routes. So you can call it to private subnet, and you specify the subnet, a private subnet at the prefix, and you choose virtual appliance, and you choose the next hop address. So basically, that's it. So after you've done that, the third step is associate the routes, right? So this is the last step. So you just choose your virtual network, and you choose, let's say the route table. You select the routes you just defined. Okay. Very straightforward. So we're gonna do a little demonstration on that. Just let me browse to my, I don't think it's this one. So let me switch to the, oops, I should just click through that. Yes, here. Okay. So we search route table here. I already have two here, right? So you can add another one. You can give it a name, subscription, resource group, and location, right? You choose that. And be careful, the location must be the same with your virtual network, right? So this is not mentioned in the PowerPoint. If it's not in the same location, the virtual network cannot be able to associate with that, right? It's something you have to know. So I already have one here. Let's say it's my route table public, right? So same name. So I have one here, right? You can uh, click routes. You can add another one. Prefix, define your IP address range actually, and you choose whether that is a virtual appliance, and you choose the next hop, right? So after that, you go to your virtual network. Let's say my lab network Japan East. So you go to the routes. So where's okay, let me just search. Oops, sorry, it's not called route, my bad. So it's called route table. I think it should be something here. What? Let's see that. Give me one moment. I want to know why I missed that. Oh, no. Show default. See this one. Okay, it's here. So you have to click into the VNet. So the subnet. So my bad. You have to click into the subnet. It's not associated on the VNet level. It's on the subnet level. So where you just define that, associated with the route table, you just choose. All right. So it's simple as that. Okay. All right. So let's continue this without the demonstration. Azure load balancer. Right. We're gonna divide into all this 7 uh, slides actually. So Azure load balancer. The Azure load balancer, what's typically the load balancer do is deliver the high availability and network performance to your application. So it's a layer 4 in the OSI module, so TCP and UDP level. So load balancer that's distributes inbound traffic to backend resources using the load balancing rules and health probes. So typically the load balance, if you ever done that in your on-prem environment, you know there's two, right? There's hardware load balancing and there is software load balancing. So the software load balancing, you have this we call the DNS round robin, right? So it's myself, it's in the round. Okay, it's a bad joke. So it's a round robin, so which basically it distributes incoming traffic. So this one maybe go to server A, another one go to server B, and another one may also go to server B. So what's bad about that is once a server is down, let's say server 1 is down, the software load balancer, the round robin doesn't know. It will maybe this package is still sent to server A, so that will be the package will be dropped. In this case, the fail to access the resource. So what the hardware load balancing does is it's much better. So it's check on the network level, see which one is available. And that's much better because it's also very expensive. So you should actually require a piece of hardware to do that. So for an enterprise customer, they always choose the latter one. They use the hardware load balancing, right? So and that's generally some extra information you might know. Okay, so that distributes the inbound traffic to, as we talked about the resource using the load balancing rule and health probes in Azure. So the load balancing rules determine how traffic is distributed to the backend, and the health probes ensure the resource in the backend are healthy. The load balancer can be used for inbound as well as outbound scenarios and scales to millions of flows for any of your TCP and UDP applications. So keep this diagram in mind since it covers the four components that must be configured for your load balancer. So the front-end IP configuration, back-end probes, health probes, and load balancing rules, right? All that is covered in this. It's very straightforward to remember. So talk about the public load balancer. So there are two types of load balancer. There's a public, there's a private. My bad, it's not private, it's internal. So it's yeah, it's hard to because obviously ITU you could talk about private and then private or external and internal. This is one it's actually public and internal. So a public load balancer maps the public IP address and the post number of incoming traffic to the private IP address and port numbers of the VMs and vice versa for the responsive traffic for that from that VM. So applying the load balancing rules, you can distribute your specific type of traffic across your VMs or your services. For example, you can spread the load of incoming web traffic across multiple web servers. And the following figure shows the internet clients sending web pages requests to the public IP address for web application on port 80, right? So the Azure load balancer distributes the request across the three VMs in the load balancing, we call the load balancing set, right? Okay. And another one is the internal load balancer. So internal load balancer directs traffic only to the resources that are inside the virtual network or that use the VPN to access Azure infrastructure. The front-end IP address and virtual networks are never directly exposed to the internet endpoints. The internal line of business application runs in Azure can accessed from within Azure or from an on-premise resource through VPN. So for example, internal load balancer could receive database requests like we saw here that need to be distributed to backend SQL servers. So internal load balancer enables uh, these three types three or four types of load balancing. So within a virtual network, from a cross-premises virtual network, from a multi-tier application, and for line of business application. So four, yeah, we list here. So within a virtual network, right? So load balancing from the VMs in the virtual network to a set of VMs that resides within the same virtual network. A cross-premises virtual network. So it's load balancing from on-premises computers to a set of VMs that resides within the same virtual network. And multi-tier applications, it's load balancing for internet-facing multi-tier applications where the backend tiers are not internet-facing. So this backend tiers requires traffic load balancing from the internet-facing tier. And your line of business applications is hosting the Azure without additional load balancing, hardware or software. So this scenario includes the on-premises servers that are in the set of computers whose traffic is load balanced. Okay, now we need to talk about the SKU. So when you create the Azure load balancer, you will select the type, right? So it's internal public for load balancing. You also select the SKU. So the load balancer supports both the basic and standard SKU. So each differing scenario scale, so features and pricing, etc. The standard load balancer is the newer load balancer product with the expanded and more granular features set over basic load balancer. So it is we call the superset of a load balancer. And there is some general information about the SKU. So it's not mutable. You may not change the SKU of existing resource. You cannot switch, not like you can upgrade a virtual machine or downgrade that. So a standard virtual machine resource availability set resource, virtual machine skill set resource can reference one SKU but never both. So you can usually set one for the entire resource you choose. Load balancer rule can span two virtual networks, front end and their related backend instance must be in the same virtual network. And there's no chart for basic load balancer. So the standard load balancer is charted based on the number of rules and data processed. And the last one is load balancer front ends are not accessible across global virtual network peering. Okay, you can check out what we talk about network peering in the previous session. And another is backend pool, right? So what is a backend pool? So to distribute the traffic, a backend pool, address pool, actually contains the IP address of the virtual NICs that are connected to the load balancer. So how you configure the backend pool depends on whether you are using the standard basic SKU, sorry. So the backend pools are configured from the backend pool template. For the standard SKU, you can connect to an availability set, a single virtual machine, or virtual machine skill set. And in standard SKU, you can have up to 1,000 instance in the backend pool. So in the basic SKU, you can only have up to 100. So that's something not listed in the table actually. And load balancing rules, right? So a load balancer rule is used to define how traffic is distributed to the backend pool. The rule maps a given front-end IP and port combination to a set of backend IP address and backend port combination. So to create the rule in the front end, back end, and health probes information should already be configured. So here's a rule that pass front end TCP connection to a set of backend SQL server, port 1433 server. So the rule uses a health probe that checks the TCP, what's the number I just said? 1433. So it's bad memory. Right. So okay. So session persistence. Okay. And by default, the load balancer distributes the network traffic equally among the VMs, all the instance. The load balancer uses the 5 tuple, so source IP, port, destination IP port, and protocol type. Those 5. So those hash to map traffic to available servers. It provides stickiness only within a transport session. Again, the OSI module. So the session persistence specifies how traffic from client should be handled. The default behavior which is none, is that successive requests from a client may be handled by any virtual machine. So you can change these behaviors if you want. So the client IP specified that successive requests from the same client IP address will be handled by the same virtual machine. And the client IP and protocol specified that successive requests from the same client IP address and protocol combination will be handled by the same virtual machine, right? And health probes. So a health probes allow the load balancer to monitor the status of your app. The health probe dynamically add or remove VMs from the load balancer rotation based on their response to the health checks. So when the probe fails to respond, the load balancer stops sending the new connection to the unhealthy instance, which makes sense, right? It's how the hardware load balancing works in a way. So there are two main ways to configure the health probe. So it's HTTP and TCP. The HTTP custom probe is this load balancer regularly probe your endpoint. So actually every 15 seconds, as I said here, every 15 seconds. Where's my mouse? Yeah, 15 seconds. So this is by default. The instance is healthy. Uh, so if it is healthy, it's responds with the HTTP 200 redirect within the timeout period, which is 31 seconds by default. Any status over that, then the HTTP 200 will cause the probe to fail. You can specify the port, URI, or requesting the health status from the backend URI. Amount of time between the probe attempts and the number of failures that must occur for the instance to be considered unhealthy. So that time you can request as they specify here, right? So port, pass, interval, unhealthy threshold you can specify. And the TCP probe. So this probe relies on establishing a successful TCP session to define probe port. So if this specified listener on the VM exists, the probe succeeds. If the connection rejected, the probe fails. You can specify the port interval and healthy threshold as well, right? The same thing. Okay, so that's our session for now. I'm not doing this because uh, I tend to not grow. It's grow on me. I need to divide into two sessions. But anyway, I will upload the entire uh, PowerPoint PDF version of this deck to the SharePoint where you can download. All right.